So we're still on inverse trig functions. Inverse trig functions. So then we're going to quote inverse of x being equal to y. So then I'm trying to find dy by dx because y is the function of x. So we go ahead with our steps. We're going to let x be a function of y by taking the quote of both sides. So we're going to have quote x being equal to quote y. So then dx by dy will give us the negative cosec squared y. Then for us to have cosec squared y, we're going to go to our parent equation. Sine squared y plus cos squared y is equal to 1. So for us to have cosec squared y, we're going to divide by sine squared y, right? So sine squared y over sine squared y over sine squared y. So then this one will cancel out to have a 1. This one will have a quote squared y, and then this one will be equal to cosec squared y. So wherever there is cosec squared y, we can put 1 plus cot squared y. So dx over dy is equal to negative 1 plus cot squared y. So then we can find dy by dx by saying 1 over dx by dy. So it's just like you're taking the denominator of the denominator to the numerator. Dy by dx is equal to 1 over the negative of 1 plus cot. This is cot squared y. So then dy by dx is going to be equal to 1 minus 1 plus cot squared y is simply cot y is simply x, so cot squared y will be x squared. Thus we've shown for this one. Y is equal to tan inverse of x. So now we let x be the function of y. We said x is equal to tan y. Now this one will be easier to differentiate, so we say dx over dy is equal to the derivative of tan y is sec squared y, and then we try to find a function that will have sec y and also tan y, so that we can replace where there is tan y we're going to put x, and then where there is sec y we're going to make sec squared y subject to the formula, so that we can replace this one and then put whatever we're going to find. So now we go to our parent equation that we always go to, our parent identity, sine squared y plus cos squared y is equal to 1. So now we make sec squared y subject to the formula, but then we don't have sec squared y. So what we're going to do is we're going to divide the entire equation by something that will make us have sec squared y. So you can divide by, in this case, sec squared y is 1 over cosine y. So when we have 1 over cosine y there, we're going to have sec squared y there. So we divide all sides by sec squared y over sec squared y, cosine squared y over cosine squared y. So then here we're going to have tan squared y plus, this one is just a 1, and then this one is a sec squared y. Yeah, so this sec squared y is exactly what we've been looking for there. So you can replace where there is sec squared y and then put tan squared y plus 1. So then our dx over dy is being equal to tan squared y plus 1. So now we are differentiating with respect to y. So in this case, it's okay for us to have the y there, but then what we are really looking for is dx dy over dx, because y is the one which is a function of x in this case. So now dy by dx is equal to 1 over dx by dy. So dy by dx will then be equal to 1 over dx by dy is tan squared y plus 1. So now our variable of differentiation is x. So then in this equation we must have x and not the tan squared y. So then we look at what we let our x equal to, and then wherever there is tan y we're going to put x. So dy over dx is equal to 1 over tan y squared plus 1. So dy by dx is equal to 1 over x squared plus 1. So that's it, and if you've forgotten you can try to derive using this method, but if you're good at memorizing you might as well just memorize it.